Okay, can we get started now?
Yes, sir. Please start the lecture.
Okay,
Okay.
so we have two more lectures to go. So this one is about herbal AI. Uh, we first look at the herbs and the traditional medicine, and then we look at the relevant databases, and then we will focus on the main objective of today's lecture, the AI for herbal medicinal research, and including the diagnosis of for traditional medicine. Okay, so we know that herbs, some herbs have this kind of medicinal benefits. So these are some of the well-known medicinal herbs like ginkgo, ginseng, Senjiangzuwort, and so on and so forth. Even garlic, some actually mainly used as a food. So regarding to the medicinal benefits of herbs, and we want obviously we wanted high quality herbs. So the quality control, quality assessment of medicinal herbs are very important things. Essentially, there are many different methods, technologies developed for the assessment, the analysis of the quality of the herbs. So here are the summary of the historical developments of the quality assessment methods, technology for medicinal herbs. And also, medicinal herbs are also becoming some kind of important part of modern medicine. For example, in NIH of the United States, they developed some mobile apps for herbal products. They, in recognition of the popular use of the herbal products, they developed the modern technological assessment tools for people to access the relevant information. In order to support the relevant research as well as the popular use, popular knowledge of these herbs, NIH has also developed websites providing more detailed information about quite a number of medicinal herbs. Regarding to medicinal herbs, we know that in traditionally many different populations in the world have widely utilized herbs for therapeutic applications, particularly in the form of traditional medicine. Here is a history of traditional Chinese medicine. So it started to more than 200 years before the current the age counting before Christ. So essentially, long time ago, they actually came up with a very classical book of traditional Chinese medicine, TCM, very famous book, and also there are some books that actually even had the important is also the important guidance even today. So there are some very famous groups. So you can see the history continues to develop with more and more recipes and more advanced, refined theories, and until the current even the current development includes the employment of new technologies. For instance, the edge they developed apps, right? So the new technology, including the modern way in facilitating the diagnosis based on the traditional methodology of visual inspection, observation, audio inspection, questioning, and pulse measurement, these kind of things. So there are modern equipment, even some kind of wearable device for this kind of measurement observation that actually uh, detect with the same effect as the traditional style doctors. So even in the World Health Organization, they recognize the importance of traditional medicine. They actually included the coding of traditional medicine in the general coding system. ICD coding system. So it is a in recognition of the importance and also the popular use of traditional medicine. Traditional medicine, they differ from modern medicine in quite a few aspects. So the most important aspect is the different approach to disease understanding and treatment. In modern medicine, typically we want to find the key mechanism, the key genes, the driver genes that actually directly drives or leads to the disease progression. In traditional view, they actually view the health problem, disease condition as some kind of off balance. It is something that deviates away from a balanced health condition. Either something is more excessive, so that's called yang, right? Something deficient, it's called yin. So the excess or deficiency could be in different part of the body, like skin or internal organs, or it could be some kind of effects, even some kind of psychological perspectives. You feel something like a pain, and so on, so forth. This kind of thing. Anyway, these kind of conditions could be considered as something deviating from the balanced health conditions. And then you need to have something to interfere with this off-balanced condition to correct it, to make it going back to the healthy conditions. So what are the things to interfere? So this is also a different. So there's a difference between traditional medicine and modern medicine. In modern medicine, we typically use some kind of therapeutic drugs, and you also have some kind of radiotherapy, and so on and so forth. But in tradition, because we do not have a modern type of technology to support those things, so we typically rely on nature. So essentially, uh, herb-based medicines are the primary therapeutic approach used to interfere with these off-balanced conditions to try to correct them back to the normal. And apart from herbs, there could be some other tools like acupuncture. So essentially, you use some needle to actually interfere with some kind of condition inside the body. Either it is due to the interference with the immune system, uh, with the neural system, or with whatever. Anyway, it also people surprisingly people found out that acupuncture uh, is quite effective against certain problems. Apart from herbs, of course, there are some foods, for instance, garlic, right? Some foods, they also have therapeutic use, but they are kind of daily used foods. So the utilization of food, or so-called food medicine, dual nature type of plants. They have lots of applications, particularly for nourishment, for recovery, for prevention, even for extended life, for those kind of. That means that if you only have a slight of balance, or if you have a gradual off balance, ideally you can employ food-based therapeutic approach. So to actually uh, correct the off-balanced condition. In foods, you also have this kind of dual nature. Not only they have medicinal benefits, but they are food. So that means you have to consider the flavor aspects, how you can make them, cook them into delicious food, yet preserving the medicinal benefits. Certainly, it is in the domain of modern science. There's a lot of things to do. Even if you have plants have some effects, but how you utilize them to make the best benefit of them, certainly uh, we are not really mastering that already. We are far from mastering them. Okay. So there are also differences in the study of traditional medicine with respect to the modern science. In modern science, it is on the left-hand side. We understand the biological system from system regulation perspective, and we have these kind of a biological pathways and networks. We have this kind of regulatory mechanism, interference mechanism, uh, and then we identify the key targets for this targeted therapeutics. So that's the modern approach. But in tradition, as I mentioned, that they typically consider the whole human body as a complete system. So the alpha balance is not only the alpha balance of a targeted pathway or a targeted genetic the aspect of the problem, but it includes everything, includes the some kind of symptoms that actually goes along with the disease. So you have this kind of this kind of cooperating the symptoms, this kind of some kind of essentially accompanying uh, health problems. So the herbs, the formulation of herbs try to correct everything, not just the key problem, but also the other things related to the key problem. They should be all should be covered. So that's this question, how to bridge them together. So obviously, if you want to bridge them together, you to understand the mechanism of traditional medicine, you need to also need to consider the whole human body, the biological system, including for instance, if you have a disease in the liver, if you have a pain, it also have some effect, a psychological effect. So that means your neural system is also involved. So you could have some kind of symptoms because you have this annoying effect due to the pain and so on and so forth. It could also affect your sleeping conditions and so on and so forth. So these are the aspects that the modern medicine should also consider if you want to. The modern science should consider if you want to really fully understand the mechanism of traditional medicine. So these kind of things. With this in mind, we now focus on the herb treatment, particularly the multi-herb recipes. These are the typical recipes of traditional medicine, right? Including TCM. But if you have multiple herbs, you can understand that there should be multiple active ingredients. There should be multiple targets. So some targets may be responsible for the main therapeutic effect. It may or may not correspond to the targeted therapy. May means that it may include the target of modern medicine. May not meaning that because the intrinsically weak interference on the target, you need some synergistic mechanism to enhance the interference against the target. That means you have to target multiple sites of biological system or pathways. So that may be different from modern medicine. Actually, it's not really 100% different if you are familiar with the cancer treatment. You frequently found that some the treatment actually is based on three, four, even five different medicines. So these medicines they also work in synergy for the treatment of cancer because in cancer, particularly those fully developed cancer, metastatic cancer. So any medicine, any Western drug is actually a weak drug. It has a weak activity against the fully developed cancer, highly developed cancer. So in that case, you also need to team up the medicine. So the traditional medicine is the same. You team up these weakly active herbs or herbal ingredients and make them as a team to achieve synergistic effect. You may have more power in the treatment of the disease symptoms. Of course, in traditional medicine, as I mentioned, the symptom actually include everything associated with the disease. So that's why that could be the off balance should be. So it is on the left-hand side. The off balance should be interpreted in multiple states. So these are the or the combination of the multiple states. These are the some of the states like fire state, wind state, or wood state, and so on and so forth. That these kind of complicated systems. Anyway, if you have this kind of system, then you should have, in modern science perspective, you have something regulating toxicities, side effects. You have something in the treatment of secondary therapeutic effects, and so on and so forth. So this has to be based on the biological pathway, biological system regulation. So it is a complicated system for the study. For such a complex system, definitely you need bioinformatics because you can't simply based on individual knowledge to actually fully comprehend these kind of complicated activities of multiple herbs, multiple ingredients, and multiple, even the coverage against different organs of a human body for the treatment of a simple disease, even like a common cold, for instance. So obviously, if you want to do bioinformatics, sorry, database is the first you need. So that's why in herbal medicine, there are many database development, including the database developed by our research groups. So we are the first to develop the first TCM database for academic use. It was published in 2007 in the British Journal of Pharmacology. So we want the information, the data be available, be aware of by all the scientific communities around the world. So that's why we publish it in highly recognizable pharmacological journals. So we also published the first quantitative activity of natural product database. The first version was published in 2018, and so we updated in 2023, and we are updated this year, 2025. So we actually so actually with lots of information, quantitative activity. So these quantitative activity are mainly experimentally measured. So we provide the information of a uh, natural product activity, experimentally measured activity. We also provide the information about where in which species this natural product is produced, so that if for many natural products, there are quite a number of natural product databases, but some of them don't even include the information of the source species of the natural products. Then you cannot utilize them for the study of traditional medicine. You need the source species information before you can link it to a medicinal herb. Right? So that's the must. Of course, you can also use these database to study food because food ingredients are also highly covered in this database. There are also general chemical databases, for instance, Campbell database providing bioactive molecules, not just the natural products, but human synthesized compounds. So with quite a comprehensive coverage. In order to study the effect of traditional medicine or herbs on human body, you need to have clinical omics database. So this GEO database is a highly useful one, as it contains the transcriptomic information data for instance from humans and also from animals as well. So this kind of thing. With this database bioinformatics, and we can combine AI with bioinformatics for the study of the effect, the mechanism of herbs or the mechanism of traditional medicines. So our next topic is about the combination of AI and BI stands for bioinformatics for herbal medicine research. So here is a flow of the uh, research in the determination of the mechanism for instance, traditional medicine recipe. So we need to have lots of bioinformatics support in terms of databases. For instance, traditional medicine, TMs for traditional medicine, you need the information like recipes, herbs, ingredients, targets, right? This kind of information. So we can define these information as a uh, timidomics stands for traditional medicine omics. So we have a generalized terminology of omics. Likewise, the quantitative activity species source information, it is called of the natural products. We also need that information. So that's called chemogenomics. So we have the second omics. And then we need the third omics, which is the medicinal plant omics. So we have another database called the CMOP. It gives you the collective activity of the ingredients of the not only medicinal plants but other useful plants. So these kind of and then the last omics you need is a clinical transcriptomics database, omics database like a GEO. With this information in mind, we can start from a recipe. We have the herbs, we know the ingredients, we know the targets, and then we can analyze the target state in patients, and then we can find the clinically relevant targets of the recipes. Remember that these targets not only included the primary disease, but also included any accompanying symptoms and secondary diseases. In the end, you have a symptom target group. Of course, you have the targeted symptoms, not only the main disease. I emphasize it again, not only the main disease, but also any accompanying symptoms. So you have a target group for the whole system, and then you have a some kind of mechanism for the recipe. So, so here is an example of the TCM recipe. So this recipe obviously some descriptions are in Chinese language, but anyway, all you need to know is that there are eight herbs, herb one to herb eight, and so these are combined. So they are colored differently, meaning that they act in different roles. So the top one are the main roles, and then there are some assistants, and so on and so forth for this kind of applications. So what's the AI the use? So we combine these herbs into a recipe. So the question is whether the recipe, the combination of these herbs into a team, whether it is reasonable or not. For example, if we have a basketball, we know that the team must be five members. You can't be you have two more members on the right on the court, right? So and also you need also different player. They must play different roles. Some may be more for the offense, some may be more for the defense, right? Some may act as an organizer to ensure the ball goes to the person with the best opportunity to score, right? So these kind of things. So so you know that there must be some kind of, and also different role, the player different role requires different characteristics. So for those offensive roles, they must have a high accuracy in scoring, in putting the ball into the basket, right? And then for the defensive low players, they need to be very strong, reacting fast, and also highly resolute, highly competitive. Don't mind to actually bump to each other, those kind of characteristics, right? So these kind of characteristics also must exist in the properties of the herbs. So definitely the team up must have some synergy in terms of the characteristics. So this synergy should be recognizable or recognized by AI. So we can develop AI to actually judge whether the recipe is a valid recipe or not. So this is the things. So in order to do this, of course, we need the something that can describe the properties of the multiple herbs. So I will give you a later example how to digitize the traditional properties of the herbs. Once you have the properties of herbs, you can send, for instance, to a machine learning method to separate the valid recipe from the invalid recipe. So purely based on the properties, the properties actually is some kind of features like much like the cardiogram features, and then AI actually try to recognize the pattern and then find a lightened space to for this kind of separation, this kind of thing. Okay, now we look at the how we digitize, formulate the coding of traditional herbs. So this is an example of a particular herb. So this is one herb. So in TCM, so each medicinal herb is described by the nature or character. So that's the first category. of the properties. So in nature or in character, it means cold, extreme cold, minor cold, hot, and mild, etc. These kind of things. So there are these kind of things to describe the nature or the character of the herbs. So the second category is flavor, like pungent, sweet, sour, and so on and so forth. Bitterness, so forth. So we have a flavor character, and then you have this toxicity, meaning that it is literally it means the toxicity, whether it is toxic to or extremely or slightly. So, and then the last, actually, not the really last, actually the last major characteristics is the meridian. So essentially, it tells you the herb may be more effective against a certain traditionally defined organ. It's not really the modern, not necessarily modern organ. For instance, liver in TCM not is not only cover the liver, but also cover some other aspects because the liver, the main functionality of the liver is metabolism. So anything that could be related to the metabolism effect may be included into the liver. So it is not only the liver. But anyway, these are the traditionally defined the so-called organ, and then so they are uh, under this category, meridian category. And then there could be some miscellaneous, so I don't know how to translate them into English, so I have to tentatively put them the Chinese word. Anyway, these four, nature, flavor, toxicity, meridian, these are the main characteristics, and we need to digitize them. Okay. So the digitization, I think we are almost the expert now. We know that we digitize for instance, the human language, right? We digitize many different things using one hot encoding, 0101. So essentially, you do the same thing for the nature or character, right? Remember that in nature we have a code, extreme code. So if code is the position one, if you have a herb that is code in nature, you can put a value one in this position, and the other position are zero. So this way you generate a one hot encoding. For flavor, it is the same thing. Meridian, same thing. Toxicity, same thing. So in the end, you have this kind of multiple vectors to represent the character, the flavor, meridian, the toxicity, and so on and so forth. Right? And then later on, you just need to combine them. The combination could be very simple. You simply align them together. So that's a typical approach. Of course, there are other formulations to actually combine the multiple one-hot encoding system into one system. So essentially, with this in mind, with this encoding in hand, not in mind, in hand now, we are ready to develop an AI for this recognition. So this is the first paper so published in 207, utilizing AI for distinguishing TCM recipes, prescriptions with non-prescription recipes. So AI can really, just like AI can recognize human any object, right? Flowers or the so on so forth. Okay. Okay, now we look at the second application of AI. Remember that we talk about this kind of flow of the research. In analyzing this target clinical relevance, we could employ AI to do this. Essentially, we use this, for instance, we can use hierarchical clustering AI to analyze the clinical relevance of the target of the TCM recipes, for instance. So this is exactly what we have done in the study of the mechanism of TCM in the treatment of COVID-19. In 2020, when the COVID-19 pandemic becomes widespread, so the Chinese, the government, so they have this National Health Commission of China. They recommended quite a number of recipes. So here are the recipes. Uh, recipes. So the recipes, some recipes are for mild cases, some for general, some for severe or even critical cases. You have these kind of recipes. So our objective is to study the mechanism why these recipes can be useful in the treatment of COVID-19. So that's the task. So we follow this kind of uh, the strategy to start from the recipe, herbs, ingredients, and the targets, and so on and so forth. But we do one step further. So this is the a more detailed workflow. So we start from the recipe TCM, a particular TCM recipe recommended by the National Health Commission of China. And then we extract the TCM ingredient information from TCM ID database. We extract the target information from NPAS database. Remember, I talked about these databases. And then we analyze the clinical state of these targets using unsupervised clustering AI, and then we generate this heat map. The bright red region are the active target information. So each column represents one patient. Each row represents a target, a gene. You can see that many targets, even though they are valid in the sense that they are the targets of some of the herbs here in the recipe. So they are the targets, but sorry, these targets are not active in the patients. That means the herb, the recipe are not going to be effective based on these targets. So they can only be effective based on those active targets. So these are the active targets in the patients. You can see that collectively the the recipe can cover quite you can see these patients are covered, right? So these patients are covered here. So these patients are covered by this target. These are covered by this. So collectively, they cover quite a large percentage of the patients. We published two papers, one from this AI, using this AI approach to generate this, the other from the comparative comparison with the Western, the targets from Western medicine from that perspective. Our paper is titled East Meets West in COVID-19 Therapeutics, published in June 9th of 2020 in Pharmacological Research. So that paper is actually included in the COVID-19 page of the WHO. This way we tell the world that East and West, the TCM, Eastern medicine, traditional medicine, they are not really entirely different from Western medicine because they share some of the same targets in the treatment of COVID-19. So that's the message of this particular paper. So here are the detailed list of the targets. You can see these are the herbs from the TCM recipes. So these are the ingredients. So these are the targets. Uh, and then so these are the activities, experimentally measured activities. You can see some activities are quite strong in the nanomolar activity range. So that's why they are called high potency target. And then you have this hierarchical clustering of these targets. You generate heat map, this heat map, and then and then this is you can highlight the most active part. That means the brighter red parts. So these are the true targets. So in the end, if you count the number of targets, it only there are only 7 targets left. They are elevated in patients. So these are the patients. Patients. You can see that. Okay. And in the end, not only we can interpret the mechanism, but also we can assess how effective, in which percentage the recipe actually are effective against the COVID-19 patients. So these are the specific recipes. So these are you can see are the targets. So this table actually is from our publication in 2020 published in Pharmacological Research. You can see the targets here, they actually cover 17 or 15% of the patients. And then the effect is to reduce the DC and the T cell mediated inflammation. So that's so actually constrainment reduction of the immune cell mediated excessive inflammation is the major mechanism. Actually, that's the major mechanism that causing the damage, causing the death of the COVID-19 patient. So you can find that truly our study actually points to these targets. They are all related to the immune cell enhanced mediated inflammation, so on and so forth. Okay. So the last topic is about the diagnosis. As I mentioned that traditional medicine, they actually target not only the main disease, but also the human response of the disease before the treatment, without the treatment. So obviously disease itself may be due to common mechanism, due to common target, but certainly response must be personally different. So in order to be able to give the right combination of herbs to treat not only the disease but also the accompanying symptoms, the problems. That's part of the response, right? You need a personalized diagnosis. So the question is whether the AI can facilitate the diagnosis. Okay, so here is a example of the pulse diagnosis. Depending on the shape of the pulse, there are different interpretations of that they reflect the internal state of the human system and also including the health conditions and the potential response to the interference, and then so that you can determine what kind of combination of recipes you should give to the patient. So for instance, uh, you can see the difference of the patterns of the pulse. This is you can see the more deep this kind of deep rise and down the pattern. You have this mild increase called the sync, and then there's this moderate ones. This kind of things. And also there are this kind of irregularity, and also you have this. So this is the normal one. So this is obviously also abnormal. There are all sorts of patterns. Obviously, as the pattern goes, more a variety. Definitely, it's better to use AI for this recognition. Even for the observation, for instance, observation of the face and there are many different part of the face that reflect different organ conditions. So you need to look at the face based on the tone and these kind of things. There are many different things. So we have this face recognition AI. Obviously, we can apply the AI for recognizing any change of the tone in different parts of the face. Also, likewise for the tongue, it is the same thing. You can actually so different parts of the tongue also reflect the different condition of the organs. So you can also have this kind of observation. Regarding to meridians, not only the meridians, so these are also meridians actually, not only the meridians of the particular organ, but also it can be reflected in other parts of the bodies for the observation. So the most probably the one is using the palm meridian. You can see it is highly complicated. The next example is the okay. So now we want to look at how we can apply AI for pulse recognition, pulse pattern recognition. So this is example of the pulse wave, right? So we can divide the pulse into segments. That's no problem. So segments, and then we focus on the recognition of the patterns of the segments. So each segment could be transformed by using fast Fourier transform into this spectrogram. So it looks more like a image rather than this kind of wave form of the data. You have this kind of, so that's why it's called a spectrogram. This kind of uh, data. And then so you can directly input the spectrogram into AI for this pattern recognition. So you can simply utilizing a CNN image recognition AI for this spectrogram recognition. So that's one example. Of course, there are more complicated approach, not really relying on spectrogram, but on some other things. So because of the nature of this lecture, I'm not going to go to too complicated things. Anyway, so if I'm interested, remember that we mentioned about spectroscopic AI, right? So some of the AI tools, AI architecture, AI model can be directly utilized for pulse recognition for this kind of application. So I'm not going to go to the more details here. Okay, let's stop here for today. So now is question time. So do you have any questions?
Okay, thank you, Professor. Let me ask from physical participants. Do you have any question? Anyone? Sir, do you have a question? Yes, please. Please introduce some questions.
Hello, Professor Chen. I am
Oh,
Fazal Waid, working as a research assistant at Qaid-e-Azam University, Department of Bioinformatics. I have a question about the traditional and modern medicines. Traditional medicines have been practiced for thousands of years. But then why did the world shift it toward the modern medicines? And as we see that now the traditional practices are now emerging and even as a focus of the research, as we are talking about developing the AI models for this. Thank you.
okay, so the reason is simple. The disease actually can be divided into different classes. So you have this serious, severe disease, life-threatening disease, for instance, like cancer, heart disease, and so on. For those disease, of course, that's the priority, particularly in modern society, because we as economy develops, we have more means of more time and resource to deal with those serious diseases. But in the past, I think what human worry the most is how we can get away from hungry, right? Hungriness. So the focus is changed. For this kind of severe disease, typically they have so-called driver genes. So if we focus on the driver genes, it is more effective in the treatment of this severe disease. In traditional medicine, because we don't have a modern technique to find the so-called driving factors, and also we don't have the modern technology to synthesize new medicines. So that's why modern medicine develops into this so-called targeted therapeutics. As long as we have a driver gene, we can target that. So that made quite a big success. But for some disease, we do not have so-called single driving gene. For those problems, particularly mild disease, mild illness, you have this so-called chronic disease, and also you have these so-called sub-health conditions. For those problems, and as the economy further develops, we are not only concerned with this severe problem, life-threatening one, we also want the quality of life. Even we are still deemed healthy, but really we are sub-healthy, right? So that's why if the targeted therapeutics is not the best approach, why not we use this uh, 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 so-called balanced recovery approach of traditional medicine. We try to correct the off-balance condition using this multi-herb, even functional food, supplementary. You have this kind of supplementary health supplementary products, right, for this kind of treatment. So that's why traditional medicine, natural products, and also herb, so functional food, these are actually becoming more and more more and more focal points of the new research. Okay. Mm.
Okay, thank you, Professor.
Mm.
Let me ask from anyone have a question? No? Okay. So the next question that is by from our online participant, that is by Kinza Ashraf, and she's asking, as we use AI to diagnose and treat diseases, there is possibility that AI can misdiagnose and can be harmful to patients. Then who will take the responsibility?
So that's the in the domain of essentially it's not a scientific domain or medicine domain anymore. So essentially we need those legislation, those lawyers, they figure out a new policy regulating these kind of problems. So anyway, this concern with the role of AI. So AI is not intended as a absolute tool. It acts as a tool that should be better than any existing means. If it is better than any existing means, then it should be employed, utilized for the benefit of humanity. Regarding to the medical diagnosis, as long as it is better than a doctor that a human patient can actually access, definitely AI should play a role for the benefit of that patient. So even a human doctor can sometimes make mistakes, misdiagnose, or even incorrectly diagnose the disease. I don't know if that's the case, how our society deal with this kind of case. For instance, I don't know, but at least based on my experience, we frequently heard about patients saying that I saw a doctor, so the initial treatment is not effective, and I went back at the second one, and then maybe I found another clinic, another doctor, and he solved the problem, and it is effective. So, what should we do with the first doctor? So that is some indication what we should do with a AI. Okay. Mm,
Okay, thank you.
mm.
The next question is by Kash Mughal, and he is asking, errors in AI can be harmful for the normal lifestyle?
Can you repeat the question again?
Errors in AI can
Uh,
be harmful for the normal lifestyle?
I think the question is, I think we are more concerned whether the AI do something out of control. The error, if it is the error within the expectation, I think that's fine. As I mentioned, that as long as it is better than any current means, and we may stand for the error. But those errors, they are known, right? So what kind of mistake we know. What we are concerned with AI is that if AI uh, because the AI could be empowered with a lot of controls, automatic control, and for instance, it could control every aspects of our home, including door lock, what to cook, what to order for the free delivery. Even the delivery could be by robots, right? So everything. So that means that the AI also controls the robots. And if you are ill and you may be sent by automatic car and with the assistance of robots to the hospital. The hospital is also in many aspects controlled by AI. So if that's the case, what we are concerned that what if AI do something radical? For instance, AI is tasked to follow certain order that almost treat humans like the boss. What if AI thought that why not we treat AI the same as something else instead of the boss? Why not try that to see what happens? If the AI has that kind of thing, we are more concerned. Because remember that AI is currently is still a black box, so we don't know what the if we, and also it has the capability to revise, modify the coding to make it things better. So if it has that capability, if the code is changed, and then you know what could happen. So in that aspect, if the AI makes unexpected error, we should be really concerned. Okay.
Okay, thank you, Professor.
Uh,
I think it's all up for today. These all lecture series are so great. For tomorrow, we have a closing ceremony.
yes.
Uh,
Okay.
so yeah, that's what I want to inform you.
Okay.
And thank you
Tomorrow.
so much, sir.
Okay.
Okay,
See you all tomorrow.
see you tomorrow.
After
Okay,
lecture. Okay.
bye
Okay.
bye.
Bye bye.
Bye bye.
Mm.